Hey Hawks. So today we're going to talk about balancing equations. This is just part one of how to balance equations. And in this first part, we're just going to decide whether an equation is balanced or not. Okay. So the law of conservation of mass states that matter cannot be created or destroyed. Basically, what that is saying is that whatever the atoms are that you start out with on the reactant side, so on the side of the ingredients, has to be the same number as what you get from the product side. Okay. So in chemical reactions, the amount of particles in the reactants must be equal to the amount of particles in the product. If they are, we say the reaction is balanced. Okay, so here's an example of an unbalanced equation. We have CH4 plus O2 yields CO2 plus H2O. Okay, so if we put together a CH4 and we put together an O2, here we have one carbon atom, four hydrogen atoms, and two oxygen atoms. On the other side, we have a CO2 and we have an H2O. So if we look, we have one carbon atom, we have three oxygen atoms, and only two hydrogen atoms. In order for this to be balanced, both sets of numbers have to equal exactly. Okay, so if we balance this equation and we put a 2 in front of the O, this is called a coefficient. Now we have two oxygen atoms, molecules, sorry. And so if I look at this, I still have one carbon and four hydrogens, but I have four oxygens. And then on the other side, I now have two water molecules. And so I have one carbon, four hydrogens, and four oxygens. So now the numbers are exactly the same, right? So that means that this one is balanced. Okay. When balancing a reaction, you always need to start with counting. And you're going to count the number of atoms on each side of the arrow. Okay. So I always start out with kind of a grid, and you don't have to make it this fancy, but just, like a T chart. And on the left-hand side, I put the atoms that are the reactants. That should be a lowercase a. And then on the right-hand side, you put the products, the atoms that should be in the products, and then you count how many of each there are. If they equal each other, then they're balanced. So on this one, I have a coefficient, which is the number of molecules, right? So I have two hydrogen molecules. The 2 affects all of the atoms in that molecule, right? So this 2 affects the H and the O. A subscript is the number of atoms. That only affects that one particular atom, okay? So here I have two hydrogen molecules, each have two hydrogens. So that makes 4 hydrogens, okay? Here I have, we don't write ones, right? So I have one oxygen molecule. So there are 2 oxygens. So if I look at my example, I have 2 sodium atoms. So 2 times 1 is 2. And then I have 1 chlorine molecule, which is 2 chlorines together. So I have 2 chlorines. So that's my reactants. On my product side, I have 2 sodiums and 2 chlorines. So I have 2 sodium chloride molecules. Okay, so 2 sodiums, 2 chlorines. That 2 carries over to both of them. Now I look at the how many's, they both match. So that means that this is a balanced equation. Okay. All right, let's look at another one together. and see if this one is balanced or unbalanced.